Okay, so 5.5, page 252 here. 5.5, we're getting into two different ways to prove triangles congruent. Okay, two different ways. We already had SAS, we had definition of congruent triangles. We're getting two more. Okay, so we had SAS, now we have SSS. SSS, of course, stands for side, 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 meaning that we have all three pairs of sides congruent in our two triangles. Okay, you see that here. We've got all three pairs of sides being congruent. We have all three pairs of sides being congruent. That's enough information to say that these two triangles are the exact same thing. And we don't have to know any information about the angle. All we have to know are the sides, and that's enough. Okay, just like side, angle, side, we only need three pieces of information. That's going to be a common theme throughout all of these shortcuts, is we need three pieces of information. It's just a matter of which three, right? So here we have side, side, side. You see here with your three sides, these are congruent. Okay. We could prove this if we wanted to in real life. I've done it in the past where I've given three specific sizes of straws, right? Three specific sizes of straws. And then, you know, I give them one each to everybody and I say, all right, create a triangle. And every single triangle in the entire room is going to be the exact same. Okay, it has to be. It might be flipped, it might be turned, right? But it has to be that same congruent triangle. Okay, so side, side, side. We are going to see some proofs on that. Typically, our proofs with side, side, side are decently easy. Like this one we see, right? They gave us two pairs of sides in the given. All we would have to say is LM is congruent to LM because of reflexive, and that would be enough to say side, side, side. Notice a lot of times we've had LM and ML, right? We've listed it differently. But if you look at our congruency statement, this time it's LM, LM. So you really got to look at that congruency statement to figure out in what order those letters are going to be. Okay, so side, 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 pretty straightforward on that proof. Moving forward, the other thing that we got to talk about here is we got to talk about right triangles a little bit. Okay, before we get into the theorem, and they're talking about this SSA. Okay, I believe I talked about that in another lesson, but I'm concentrating on the picture here. So when we have a right triangle, we have very specific names for those sides. The two sides that form the right angle are called the legs. Now, I know this can be confusing compared to our isosceles triangle or our base angles theorem that we had, where we talked about the legs of the isosceles triangle. These are also called legs, okay? Different type of triangle, doesn't mean it's isosceles. It just happens to be that we call these legs as well. So we got a right triangle, we got our legs that make up that right angle, and then the hypotenuse is the side across from the right angle. Okay, it's the one that does not form that right angle. A hypotenuse is always going to be the longest side. It's always going to be across from that right angle. Okay, so we have to know the difference between where our hypotenuse is located, where our legs are located. Okay, so make sure of that. Make sure we know the definitions of those, especially hypotenuse. It's the side opposite the right angle. Okay, now that we have our definitions down, we're going to use what's called the HL theorem. Okay? And this is hypotenuse leg. Hypotenuse leg. HL. So this is saying in two right triangles. So we have to know that they are right triangles first. We have to know that we have right triangles. In two right triangles, if we have one pair of legs congruent and the hypotenuses congruent, then that's enough to say that the triangles themselves are congruent. Okay, it has to be a right triangle though. This is that side-side angle sort of thing, right? Where we don't have the included angle, we have a different angle. This only works if that other angle is a right angle. Okay, that's the only time this situation is going to work, is when it is a right triangle. So I said you have to know three pieces of information. Okay, that still holds true. We still need three pieces of information here. We need to know that we have a right triangle. That's one piece. You have to have in your proof that these are either that these are right angles or that they are right triangles. Once we have those, that it's a right triangle, we have to have two pairs of sides. It has to be one pair of legs and the hypotenuse being congruent if we're going to use HL. If they give us both pairs of legs congruent, well, then that's just SAS. Okay, so just because we have a right triangle or two right triangles does not mean that it's guaranteed to be HL. It's something that we can look for is HL, but it doesn't mean it's going to be HL guaranteed. It could still be SAS. Okay, so we got to look at what information they give us. If they give us hypotenuse and one leg, then it is HL. Okay, HL for them. So this now becomes our third shortcut. We had SAS, we had SSS, and now we have HL. Okay, you got to know the situation. We're going to add two more in the next section. All right, so you got to know those situations and know when you're going to use which one. Let's look at proof of it. If you look at the proof here, what we're trying to say, they give us a lot of information here. If we look at what we're trying to prove, okay, always important. We talked about this the other day. Always important to know which triangles you're trying to prove congruent here. And which triangles we're trying to prove congruent. WYZ and XZY. Okay, so WYZ, we're looking at this triangle, and we're looking at XZY, we're looking at this triangle. So we are looking at the ones that overlap here. And I've said in the past that a good way to keep these straight is to redraw them, separate them. So you know exactly what it is you're dealing with. I've got that one over there. I've got this one over here. That's X, Y, and Z. This is W, Z, and Y. So if I'm going to use those ones on the outside to mark stuff, that's going to help me see what information I have last time. So here we have WY and XZ are congruent. Okay, so we've got that information. We've got WZ is perpendicular to ZY. Now, perpendicular, guys, that symbol right there, that is the perpendicular symbol. That is not technically the right angle symbol. That is the perpendicular symbol. Okay, they tell us it's perpendicular, we put it perpendicular. We've just used all along the fact that it's perpendicular means it's a right angle. That's right, because that's the definition of what perpendicular means. If it's perpendicular, it's going to be a right angle. Okay, so we've got that true, we've got this true over here. And what that means, guys, because they told us that they are perpendicular, they didn't tell us that it's a right angle. We need to add that into our proof somewhere. We need to have that into our proof that because they are perpendicular, it means they're right angles. We have to specifically somewhere in our proof say that angle WZY and angle XYZ are right angles. I think the book even takes it one step further and says that these are right triangles. And remember, I said, as long as you have the fact that they're right angles, I'm okay with that, and take it one step further. So we have the fact that they are right triangles or right angles if we write that in the proof. And I'll show you the proof in a second. If we show that in the proof, then we can use it. All right. The only other thing we need to use HL, because it is a right triangle. We know we have one pair of, or our hypotenuses are congruent. We need one pair of legs to be congruent as well. So we got to find that. We used up all our givens. We got to find it somewhere. Hopefully you see it, you recognize it. We got ZY, we got YZ are the exact same here. They are the same segment. So we can say that those are congruent based on reflexive property. So reflexive property is going to tell me if those are the same. ZY, YZ, again, ZY, YZ, they match up. And so now I have the fact that they're right triangles. I have the hypotenuse congruent. I have a leg congruent. I can use HL. Let's take a look at that proof. Incomplete here. Okay, the proof that they have. And look, they redrew them side by side. I don't like the fact that they redrew them not the way it looks here. I think it's better to just split them up like this so that we can take a look at how they look. Just if we can imagine it, kind of spread apart. They redrew it a different way. But you see it here, right? We had that given, we had this given that they were perpendicular. The fact that they are right angles, that's our definition of perpendicular lines. Okay, that's the reason why we can say they're right angles is because they are perpendicular. That's what it means to be perpendicular. Like I said, they went one step further. They said these are right triangles. Definition of right triangles, it has a right angle in it. Reflexive property ZYYZ, and then HL to round it out there. This is, a classic use of HL. You just got to make sure, again, you got the fact that they're right angles or right triangles. One of these is fine. You need the hypotenuse, you need the right. Okay, so really that's what it comes down to here. Those are the only two new things that we've got. These two new theorems, you got side, 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 you got HL. So pay attention to what information they give you. See if you can find all of those other pieces that you need. We are getting into proofs, so okay, it's a lot of proofs. The other types of questions you're going to see are just, is this enough information to prove that these are congruent? You'll see some questions like that as well, but we are going to see quite a bit of proofs moving forward here, at least for the next 3 sections. Actually, all of them heading into the test. So there you go. If you need to watch it again, look in the book, watch the videos on the book, do what you need to do to understand 5-5, side, 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 and HL.